Have you written Spring Boot web services with Java? Maybe you have thought about trying Kotlin. Hey everyone, welcome to my channel. My name is Arho Huttunen, and in this video we will take a look at some tips and tricks for writing Spring Boot web services using Kotlin. I've been using Kotlin with Spring Boot for a couple of years now, and coming from a Java background, I have stumbled upon some things that work a little differently in Kotlin than Java. Okay, so that being said, let's dive right into it. In this tutorial, we'll be using IntelliJ IDEA, and the easiest way to set up a project is to use a Spring initializer. So we're going to create a Gradle project with Kotlin here. Next, we'll add the Spring Web module to the project. And when we click Finish, IDEA will create a project for us. Now, if we look at the Gradle build script that IDEA generated, we can notice a couple of things. First, the initializer added a Spring Boot Gradle plugin. Second, the initializer added a Spring Dependency Management plugin. And then there is also a Spring plugin for Kotlin. This is an important part, because Spring requires some Spring annotated classes to be open Kotlin classes, and Kotlin classes are final classes by default. That will make using Spring with Kotlin a little inconvenient, so this plugin adapts Kotlin to those requirements. So the next notable thing is the Spring Boot Starter dependency and a JSON serializer extension for Kotlin. Other than that, there's just the standard Kotlin libraries and the Spring Boot starter dependency for writing tests. Finally, this compiler argument here basically means that you will have compile time null safety for the Spring framework with Kotlin. In Kotlin, all you need for Spring application is an empty class annotated with the Spring Boot annotation class. We can then launch the application calling this run application method. So, running the app, we can see that it starts up a Tomcat server. It doesn't do anything yet, but the server is up. Okay, so let's start by creating a person controller who deals with handling REST calls. First, we'll make this REST controller, and then it's time to add some endpoints. We can add a post endpoint by annotating a method with the post mapping annotation and giving it the endpoint path. Next, we'll want to make the method accept a person instance. And since we don't yet have a person class, we'll create one. Now this can be a data class, and for simplicity, we'll assume there are only two fields, an identifier and a name. In the controller, to tell Spring that the method argument is the body of the request, we'll annotate the parameter with request body annotation. And we'll want the method to return a representation of the saved person instance. For now, we're going to just return the person back because we are not yet persisting anything. So now we can write the test for the controller. We'll start by annotating the test with the web MVC test annotation, which will set up us what we need to test the web layer. Now let's first test that creating a person with post returns a person representation. We'll first have to add a mock MVC instance to the test class and auto-wire that. So here comes a part that is different from Java. We can use mock MVC DSL or domain-specific language to write our REST call. So when in Java you had to call perform, we can just call post and then add a closure here to add the arguments that we want. We'll add content here, but we also want to map some person instance to JSON, so we'll add object mapper to the test class and auto-wire that too. So now we can map the person instance to JSON in the request content. The next thing we can do is to add an and expect block here. So we can now declaratively add our assertions. We want to check that the returned JSON includes the identifier and name of the person. And we can use some JSON path matching for that. This is also different from Java because you don't need to import anything but just use the DSL. So when we run the test, it fails. And browsing the results, we can see that the HTTP status was 415, which means unsupported media type. So we just forgot to provide the content type of our request. Let's add application JSON there and rerun the test. And we can see that it now passes. So another thing that we might want to check is that the post request returns HTTP created status on success. Let's just add all of this and now check that the status is created. However, running the test, we can see that it fails because the status code was 200. So we have to go to our controller and add the created status code to the method. And now we can see that the test passes. So another thing we might want to add here is the validation of the request body. To do that, we'll first have to add the Spring Boot Starter validation dependency. Now we can add the valid annotation to the request body. Next, we'll add a not blank annotation to the person name, which basically means that it cannot be null or empty. So let's write a test that makes sure that HTTP bad request is returned when validation fails. We'll create a person with empty name and then assert that the status is bad request. But when we run the test, it actually fails. We can see that the name in the request is empty. But then we also see that HTTP 201 or created was returned, so the validation did not happen. What actually happens is that Kotlin applies the not blank validation to the constructor parameter, while the JavaX validation expects those on fields. So we have to actually annotate this field : not blank. And now when we run the test passes. We can see a warning about method argument not valid exception in the logs. However, when a validation error happens, it would be nice to inform the user about the failed fields. So let's add an assertion here that expects a violations array to be present in the response. This of course fails, so now we have to write an exception handler that translates the exception to something useful. So let's start by writing a constraint violation advice. We'll annotate this with controller advice. And we'll write an exception handler for the previously mentioned method argument not valid exception. Now we want this to return some kind of error object. So let's add a data class for a constraint violation problem, and it will have a list of constraint violations. And a constraint violation data class has a field and a message. Now the thrown exception has a binding result, which in turn has a list of field errors, and we can then map these field errors to our constraint violations. So two more things we have to do. First, make it return HTTP status bad request, and then annotate this with response body, so that our returned value gets translated to the response content. So this time running the test, we can see that it passes. We can also add a and-do print here to make it print the results even when it passes. So there we can see the response containing JSON with the violated field. Okay, so what about if this person name is null? Well, since the field is a non-null type, we cannot actually construct an object like this. But it would be totally possible that someone posted a request that does not have a name. So let's see what happens when we write the JSON here by hand. The test actually fails with a JSON parse exception due to missing value for non-null parameter. And the validation did not take place because the object needs to be first constructed before JavaX validator can validate its fields. So when Kotlin is unable to construct this object, we get this exception instead. There are basically two ways to work around this. The first one is to define a default value for this property. Since we are not allowing empty strings, this will get validated correctly. The other option would be to make the field nullable, in which case we would have to deal with nullable types then. If we cannot assign a default value for a field, that might be the only option then. So in our controller, let's add another endpoint for getting a user by their ID. Now the controller is still quite a dummy, so let's add a person repository as a dependency. We'll create an interface for the repository and add a findPersonById method. Now the get endpoint can call this method. If we write a test that gets person's details, we would probably want to mock the person repository calls. Spring test comes bundled with Mockito, and you could add a Mockito mock bean here. However, using Mockito with Kotlin is a little inconvenient. Since when is a reserved word in Kotlin, calling the Mockito when method becomes a little tricky, since you have to escape it in backticks. A better alternative in Kotlin world is to use the MockK library that is designed for Kotlin. There is also this Spring MockK library that provides a MockK bean for Spring. So now we can replace the Mockito mock bean annotation with the MockK bean annotation. The syntax for mocking is a little different. So we say every call to the person repository findPersonById with the value of 1 returns person, and we'll define the person here. Now when we make a GET request, we can add an expectation that the status is OK and the return JSON contains the identifier and the name. And it does. So next, let's handle the case when a person is not found. We'll want the call to the method to throw an exception, and we'll create the person not found exception. Now we can expect the status to be bad request, and the test will of course fail because we haven't added a handler for the exception yet. We can add another controller advice, this time called person not found advice, and make it handle the exception. And we'll actually want it to return HTTP status not found. When we run the test again, we can see that it now returns HTTP 404. So let's just change the expectation to is not found, and now we can see that our test passes. So there we have it. Those were my tips and tricks for writing Spring Boot web services using Kotlin. I hope you found the video useful. Have a great day, remember to stay curious, and see you in the next video.